This video will cover the review and reflect for the topic dividing polynomials. For the review, we are asked to match polynomial equations with their graphs. To do this, use your knowledge about the end behaviors of polynomials. Remember that the parity, the evenness or oddness of the dominating term, as well as the sign, positive or negative, of the leading coefficient will determine the end behavior as discussed in an earlier lesson. You may want to pause this video here so that you may attempt to answer the questions on your own. A quick recap about end behavior is that of the dominating or leading term has an even exponent. The end behavior will have both the left and the right ends of the graph going in the same direction. If the dominating or leading term has an odd exponent, the end behavior will have two ends of the graph going in opposite directions. Looking at the graphs and their end behaviors, we can conclude that graph A is that of a polynomial whose dominating term has an even exponent since both ends of the graph go in the same direction. Looking at graph B, we see that the ends of the graph go in opposite directions, so this must mean that the graph of the polynomial has a dominating term that has an odd exponent. For graph C, the polynomial has an even degree, and for graph D, the polynomial has an odd degree. The sign of the leading coefficient also affects the end behaviors. If the leading coefficient is positive, the end behaviors will look like the parent function end behaviors. For odd degree polynomials, the left end of the graph will be going down to negative infinity, while the right end will be going up to the positive infinity, like we would see with a linear or cubic parent function. For even degree polynomials, both ends of the graph will be going upward to positive infinity, like we would see in a quadratic parent function. However, if the leading coefficient is negative, the end behaviors would look like the end behaviors of a vertically reflected parent function. For odd degree polynomials, the left end of the graph will be going upward to positive infinity, while the right end will be going down to negative infinity, like we would see with a negative sloped linear function. For even degree polynomials, the both ends of the graph will be going downward to negative infinity, like we would see with an upside down quadratic parent function. Based on the end behaviors of the graph A, we can see that we need a polynomial that has an even degree and a leading coefficient that is negative. Looking at our choices, we see that g of x has a negative leading coefficient and an even degree of 6. So graph A goes with the polynomial g of x. Looking at the end behaviors of the graph B, we can see that we need a polynomial that has an odd degree and a leading coefficient that is positive. Looking at our choices, we see that h of x has a positive leading coefficient of 3 and an odd degree of 3. So graph B goes with the polynomial h of x. Based on the end behaviors for graph C, we can see that we need a polynomial that has an even degree and a leading coefficient that is positive, since the end behaviors has both ends of the graph going upward. Looking at our choices, we see that f of x has a positive leading coefficient and an even degree of 4, so graph C goes with the polynomial f of x. Finally, by process of elimination, or by working the end behaviors, we can see that graph D needs an odd degree polynomial with a negative leading coefficient. Graph D goes with the polynomial k of x. Now let's turn our attention to the reflect for the page. After the lecture videos, you will be able to determine the x-intercepts of a polynomial that will be used along with the end behaviors to graph the polynomial p of x is equal to 2x cubed plus 5x squared minus x minus 6. For the time being, you can determine the y-intercept of p of x by finding the value of p of 0. This will give you the y-intercept of 0, negative 6. We can also determine the end behavior of p of x. Since the leading coefficient is positive and the degree of the polynomial is odd, we know that the ends will go in the opposite directions, like that of a linear parent function. The left will be going down while the right will be going up. This concludes this video.